Hello, I'm Will. Welcome to Research Pod. Heating and cooling our homes, workplaces, and public spaces is a source of constant effort and expense. So, what can new technologies offer to help hold warmth or aid to refresh our buildings? What if one solution could do both? Today I'm speaking with Dr. Miren Juaristi Gutierrez from Eurac Research in Bolzano, Italy, about her work on innovative architectural features that could save energy, money, and carbon in future designs. And joining me from the Eurac Research Institute, Dr. Haristi. How are you doing?
Everything good. Thanks for having me here.
For everyone listening at home, and for a bit of my own background as well, could you tell me a bit about yourself, the work that you do at Eurac, what Eurac is as a whole, and a little bit about what brings us here today?
So I am an architect as a background, and when I was a child, I imagined myself as an architect, to be honest. And then within my studies, I wanted to be more confident answering to the current challenges that our planet had. And I felt that to do that, I needed to study further. So I started a PhD and I did it in the topic of adaptive facades, which I found fascinating because it was trying to change the paradigm of how we build and how we get comfortable indoor conditions. And this passion increased within my PhD. So I work on the topic, and when I finished, I didn't want to come back to the regular architecture practice that I could knew about while I was studying, doing some internships and so on. I decided to continue with the research world first with a postdoc and as a senior researcher. So I did my studies in the same university that I did architecture degree. So I got there my PhD in the University of Navarra in Spain, as I am in Spanish. But this PhD journey was also pretty international for me. So I had a period in TU Delft in the Netherlands and then almost a year in the Polytechnic of Turin in Italy, where I learned Italian. So that was also easy to then move to the research institute in the north of Italy, where I am now, and which was perfect to continue my field of study because you need really specialized laboratories and also a team to be able to do the research that I do. So it is a perfect fit, and I feel really well in this research institute right now. URAC is a private research institute in the north of Italy in the autonomous province of Bolzano. And we do applied research to improve the lives of citizens. And among the goals that we have is contributing to have a more sustainable planet. And I research on the Institute of the Renewable Energies within the energy efficient building groups, where we are contributing with our research to meet the decarbonization targets of the building sector in the European Union. So right now, if we look at the building stock of the European Union, it's accountable of the 40% of the energy that is consumed. And this means that also it is accountable of the 36% of the energy-related greenhouse gas emissions that the European Union emits. So having a sustainable built environment is really key if we want to reach the carbon neutrality targets that we set by 2050. So it's an industry that cannot continue doing it as it is with no innovation, because it would mean that we don't reach that target, which is really, really essential, not to find ourselves in a climate change scenario that is unreversible and really dramatic. So that's one of the challenge, and the other challenge is that if we think of buildings, 75% of the buildings that are already there are not energy efficient at all, which are the responsible of these emissions and energy consumptions that I mentioned. And the good or bad news is that almost all of them will still be there in 2050. So finding ways of making them more sustainable is really essential. We really, really need to do something with the buildings that we have already built there, because most of the buildings that we have right now are going to still be there in 2050. And the way they are using energy right now is not sustainable, because this means that there are many greenhouse gas emissions related to having heated or cooled spaces in our buildings. So if we don't dramatically reduce them, we will find ourselves in a scenario where we won't be able to stop the climate change scenario. But if you don't feel yourself in 2050 because you do a carpe diem person, the bad news is that the buildings as they are built right now are not even comfortable in many times of the year, because as they were built many years ago when we had other climates, they are not able to provide in us comfortable spaces. So think about heat waves that we are having. So I am sure that many of you have felt how your home is not ready or your offices are not ready to deal with it, to cope with it, and you have too much heat. So that's why we need to change the way these buildings are behaving right now by doing some interventions. I am sure you have seen many changes in the building facades, and this is the reason behind, because we need to update them so that we have comfortable indoor conditions both in winter and summer.
So we just cover some of the terms for anyone listening to this. What is meant by a building's facade? Then we get into some of the claddings and smart systems and kind of break down a little bit of the language before we get into the technology.
So building facades, let's say the physical barriers that we have between the indoor and outdoor spaces. So it's the wall that separates the building comfort zone in the inside of the building from the weather agents, so from the rain, but also from the heat or from wind. And as this is the physical barrier that we have between the two of them, they have a great role on modulating heat that is transferred or blocked from one environment to the other. That's why the facade design is so key to get energy efficient and comfortable buildings.
And what kind of facades are there? When is a wall more complicated than just bricks?
Traditional wall, at least in Europe, traditional facade, we all think of brick layer that in the best cases you have some insulation material that prevents the heat to get loose or to get gained. And finally, a coating or a finishing that makes that the facades look different, also depending on the cultural context. And right now, the benchmark or the traditional approach to make energy efficient buildings is to get this insulation layer thicker or of materials that block the heat exchange as much as possible. However, this approach of having really highly insulating buildings led us to some problems that before we didn't have in mostly heating dominated climates, where we were worried about having comfortable conditions in winter. But with the climate change scenarios, what is happening that these super insulating buildings are creating new problems. So we are having overheating in indoor spaces in summer or even mid-season periods. And this is because we insulated these buildings too much. So based on this, some of the researchers proposed a paradigm change that was the one that fascinated me and that led me to the PhD afterwards, of considering the facade not so much as a thermal barrier or a barrier to any environmental agent that can be seen as a threat, like wind or rain, but instead as a modulator. So a modulator means that we decide whether we block or exchange the heat. And in this sense, there are many technological approaches that have been conceptualized. So we only think of the facades that are opaque, so with no transmission of light. So we are not talking about windows or fully glassed facades, but the other kind of facades. We have in the literature some concepts like Pareto dynamic walls, where we have a regular brick wall if we want with that insulation layer. But the difference is that we have some openings in the top and bottom part of these walls. So when we open them, we let the air pass, and therefore we are enabling also the heat exchange between the indoor and outdoor environment. The problem of this is that we also let noise pass and also pollution. So maybe because of that it didn't reach the market maturity, or because of other reasons, but the truth is that there is not a widespread application of them. Another concept that is looking at reaching this paradigm change would be the permeodynamic insulations. So here we don't have openings. We have instead a material that enables the air traveling through the wall when there is a pressure difference. So to get a pressure difference between the indoor and outdoor environment, we put a fan inside the building to force the pressure difference, and therefore to let the air travel, and with the air the heat transfer. Also, this approach can have some drawbacks, such as with travel of the air, you have travel of dust or other particles, and therefore its durability and its ability to be permeable can be limited in time. Or maybe because other reasons, because there are many reasons why an innovation don't reach the market. The truth is that also this one is not really implemented in the real world. These are two approaches. The third one would be having movable elements. So instead of having an insulation layer that you put it in the wall and it's fixed forever, you do it as a panel that you can open or close. So when it's open, it's like virtually not having an insulation layer, and when it's closed, you have it. Here, the problems would be the space that takes to have a movable element. All this would replace the concept of traditional insulation. And the last one that I would like to mention, that for me would be the most promising one, it's the fact of having a closed loop insulation, active insulation system, where you force the air moving inside a closed panel. So here, again, forcing the air with some vents or something similar, or another fluid. When you are forcing it, you are enabling the heat exchange, and when you stop it, you have a regular insulation. And here you don't have any exchange of air or particles, so you get more robust and durable solutions. So these were some of the examples that I found within my PhD, like nice concepts, but that weren't really then prototyped and studied further.
Yes, moving from heat retention to heat management is already going to be, I think, a challenge for a lot of the building systems and the buildings themselves that exist, especially in the UK, where just everything is made to hold heat. But then to layer on the additional technology that people are working on now in making those smart management systems, how smart are we talking?
We are talking that right now we can develop algorithms that decide when we need to open and close, or when we need to move or not the air. That when I did my PhD, that I already finished 4 years ago, maybe all the advances in the control logics were not in the stage that right now we are. So right now, with very few data, we can really feel what's happening in the environment, and we can have really accurate predictions also of what's going to happen both in the external environment and internal environment, which gives us a huge opportunity to understand when we need to pass from blocking to exchanging the heat. Not just understanding what's happening right now, but also doing all the predictions and all the learnings from past events. So it's more feasible than ever, and the good news, let's say, is that we also need less sensing elements, as because we have a lot of data already there that could seem not so feasible some decades ago when they started with the paradigm change idea.
Well, that leads on to the volatility of weather, because you mentioned that being smart with algorithms and with data means being able to forecast and adapt ahead of time. This morning, where I am in England, it snowed. A good couple of inches of snow on the ground, and then by 3 p.m., beautiful, glorious sunshine, and now evening's drawing in. It's getting a little bit cloudy. How does that volatility in weather, especially like spring is going to be bad for it. Summer, we can rely on pretty much just hot. Winter, generally just cold. But spring and autumn, where weather can fluctuate, temperature, wind can fluctuate so wildly. What issues does that make for traditional architecture before we even get into how smart architecture can manage it?
So in the traditional architecture, you would have thought that in England you have much more severe winter, at least so far, respect summer conditions. So you would have calculate the amount of insulation that you need based on these morning conditions of having snow and cold temperatures. So therefore, you would have just decide to put the amount of insulation that you needed to be comfortable in that morning situation without then thinking of what would happen in the same afternoon as you just said, or even in summer conditions. What we can do with adaptive facades is that we can have this high insulation level in this morning while it was snowing, and then when the sun started shining in the facades, maybe in the afternoon, getting a really high temperatures in the outer surface, we could already exploit that heat to let it enter in our building so that when the sun stops shining, you come back to the insulation mode and you store that heat that you could have access to within the few hours that was available. And yes, we can think of summer pretty much warm situation, but even in a summer night, you can have fresher periods. So in summer conditions, maybe the same insulation layer during the daytime would have been the best design strategy as for the moment that it was snowing. But on the contrary, in the summer night, being able to dissipate, so removing this insulation or this coat, let's say, to the building, it's really needed so that it can get out all this heat from inside the building so that you have more comfortable conditions to sleep or even to within the first hours of the morning without no need of having cooling system on. So it's about exploiting the fact that the sun is shining and hitting your facade, or the fact of exploiting that you have fresher air temperature in the outside in a summer night compared to the heat that was accumulated during the day inside your building or created by you because you were cooking or having a party at home with many people. So then you need to dissipate the internal heat gains that were generated inside the building. So this is what we mean by exploiting the boundary conditions. So what is happening in the outside or in the inside of the building, it can be managed in the best way to get at the end comfortable condition that it's what we want.
Now, that sounds like it's something that is, as you said, going to be different for England, where we have the volatility, to sunny Spain or northern Italy. Is it a case of finding just the right facade arrangement for each one, or does a Pareto dynamic or permeodynamic system favor different environments? Now, to think of, rather than just a one size fits all approach, is there kind of like this technology will do well here, there, elsewhere?
In reality, so if we think of a static facade, it's much more important that we find the best arrangement to the different climates because you only can behave in one way. Instead, for adaptive facades, the best technology that then you can find, if it guarantees you that it goes from highly insulating mode to low insulating mode, that solution will be the one working a bit everywhere. So the problems that we can have with thermodynamic or paretodynamic, it's not so much that one is better to the other in an environment, but they have some problems related to the durability. Instead, if we have a facade that has a good adaptation range, it can be applied in many contexts. That doesn't mean that in all those contexts it will have the same impacts. So if we just go to put it really in extreme situation, if you go to really cold climate where you always have cold, then maybe you don't need an adaptive facade because you really need to protect from the outdoor environment always. And you don't have those spaces in or those temporary spaces where you have these warmer conditions outside or the sun hitting in such a way that can be beneficial for you. So it's more a matter of where we have a climate where adaptation makes sense because you don't have just one need, which is, well, many climates are like this or many building typologies. But then once that we are there, a technology able to have a substantial adaptation range will be the one winning.
Well, I think that leads neatly on to the work that you're seeing through URAC and the Zeraf project. Am I pronouncing that right?
Yes. Well, I'd say Zeraf, but at the end it's an acronym. So,
What is it an acronym for?
so Zeraf stands for Zero Carbon Building Enabler Adaptive Opaque Facade.
Okay, and tell us all about that.
So we are developing within this. We had this grant from the European Innovation Council Pathfinder program, where they finance high risk, high gain research that is still in low technology readiness levels, so low technology maturity levels, that if successful, they are able to transform an industry. So you should do a still pretty base research, kind of, if this exists in the architectural environment, but with a very clear market product vision. So you are in a really early stages, but with an idea that can transform full industry. So what we are working on within this project that I coordinate, it's on finding that technology that solves the issues that the Pareto dynamic or thermodynamic concept or movable insulation concepts had in order to have a robust technology that it's easy to install, that all the complexities are more intellectual and in the control and on finding the correct shade, but then it's easily manufacturable, so that we have a technology that can modulate the heat in a significant extent, to a significant extent. So what I mean with that is that we have this adaptation range that I mentioned you before really high, so that we pass from very highly insulating facade technology to almost virtually eliminating it. So this is the ambition. What we are proposing in Zeraf technology in order to have this control of the heat transfer, so to go from really highly insulating to enabling the heat going from the indoor to the outdoor, is somehow what we are proposing is to be able to change the closest to our building. And like this, we can control the heat exchange that happens by radiation, conduction, and convection. So to make this more representative example or easier to follow, think of when you have a t-shirt that it's dark compared to a white color one and the sun is hitting you, you feel really different temperature, right? So somehow this is what we are doing with Zeraf. So we are changing the color of the t-shirt so that when the radiation hits, we can have higher or lower temperature depending on what is needed. If we go then to the heat transfer that occurs by conduction, this means from particle to particle or in solid bodies. We could think of the difference of having a building that has a thick jumper compared to a thin t-shirt. So because of the amount of material that we have there, we are letting more heat pass through the building or less. And finally, we also have the example of the convection heat losses. So what happens because of the air is in movement. So here the example with the closest would be to think of the difference that you feel when you have a cotton t-shirt compared to the one that you use, for instance, to do sport that has some kind of holes inside it, right? So in the one with holes, you are letting the air that it's in movement to be in contact with your skin, which produces heat losses, so you feel less warm. So somehow we are also able to controlling this within Zeraf. So we basically change the clothes, so the color, virtually, let's say, the amount of material, and finally we change from having this t-shirt with the holes so that you, when we want, we have more losses by convection, or to pass to cotton type of t-shirt. So this would be the analogy of Zeraf with clothes in the building.
That is a high ambition. Is it approaching soon? Is it still a distant goal? What kind of progress are you seeing in Bolzano?
So we started, we are right now in 2025, March, and we started 2 years ago with this project. We started with a concept idea of the technology, and in the first 2 years, we did some further calculations in the technology concept to also improve the very first technological ideas. And right now, what we are doing is we have the first prototypes of the facade technology, and we are testing them in the laboratories that we have in URAC. So the different partners of the consortium build the different components. So from the active insulation made of biopolyurethane, coming from Indresmat in Barcelona, thanks to a concept also that we work all together in the consortium. Then also the actuators made of shape memory alloys provided by Impulse Smart Shading from Germany. And we also have a couple of more partners in the consortiums coming from the Netherlands, working on the technology concept and impact calculation. Yeah, so we have been working on making these prototypes of the concept for the first time, and now we are testing them in our labs so that we can see if we are really controlling the heat flux as we want, and so blocking it effectively and dissipating it effectively. So we are doing all the tests with the different boundary conditions that we mentioned.
Would you say that the project is borrowing well from any of the other candidates in the sector? Because it sounds like it's a very broad field for technology that might change the world. That could go in lots of different directions. Is cross collaboration in any way?
Let's say that in the world of adaptive facades, there are not many examples that reach it or manage to be prototyped and tested in such specialized laboratories as in URAC. So in this sense, we are able for the first time of having a really good characterization of this adaptation range for opaque facades. So, and I don't see many more concepts like this being tested right now in Europe. So in this field of adaptive opaque facades, we are a bit with no competition, which doesn't mean that there are not other concepts of facades trying to have carbon neutral buildings. And actually, in the research area that I am leading in URAC, we have also other approaches. So this is not the only one, even if it's the one that I am more passionate about, but I have other colleagues that works in other concepts, which is really nice. And actually then we compare the results that we get from ones to the others. So we are studying, for instance, multifunctional facades as innovative technologies to achieve comfortable and sustainable buildings. The insulation level of these facades is determined based on the expected average climate and indoor conditions. And they rely on having less greenhouse gas emission and dependency of the energy supply by producing energy on site. So there is a lot of research going on having integrated photovoltaics in facades, having in the facades also integrated the heating or cooling systems that you need so that when you renovate a building directly with the facade, you are ensuring comfortable conditions with less energy demand, and you do it everything with the facade. So this could be, let's say, a technological approach that is competing in the future if we reach the market with Zeraf, because at the end, the goal is the same: comfortable conditions with less energy and less greenhouse gas emissions. So also in Zeraf project, we are going to compare the impacts that you would get with Zeraf to this type of multifunctional facades, or also to natural ventilation. What happens just if I effectively open or close the window? Do I have similar improvements in the indoor comfort as by applying Zeraf? And when we do all these reasonings, we look at mostly, at least in Zeraf project, to three aspects. So on the one hand is the energy demand, how much energy you need to have comfortable air temperature inside your building, the greenhouse gas emissions, so that are related to the energy that you use for having comfort, but also to associated to the manufacturing of all the materials that are part of your technology. So how much emissions were associated to the manufacturing of the biopolyurethane or other components that we have in our Zeraf facade. And the last one, it's the cost. So how much is the cost of the product to manufacture it, but also how much do I save energy bills wise when I have a facade that needs less energy to get comfortable conditions. So we compare Zeraf to other approaches like natural ventilation, multifunctional facades, or benchmark facade based on these three parameters or aspects.
In a perfect world of this succeeding and lots of other ventures in saving the world coming together, where would this kind of technology fit along something like solar panels for energy capture, for electricity, building with reclaimed materials or recycled materials going into actual construction of buildings? What would the ultimate dream of a 100% sustainable building be? Is that where this is hopefully a part of it?
Yeah, so for sure, in the built environment, we have so much area that we need to exploit also to produce energy. So, as an architect, I could imagine that we use the roofs to have these photovoltaic panels to produce on-site energy. And I know also that right now there is research going on having photovoltaic elements integrated even in the transparent parts, so could be integrated there, and even in the outer cladding of Zeraf we could place photovoltaics if needed. It's something that actually we are studying. About having reclaimed materials, it's really important that the technology that we are designing right now can be then easily disassemblable, so that when it reaches its end of life, we can use those components to build other Zeta facade with other for another building or other components. So our technology it's already compatible with reuse or remanufacturing of aluminum sheets or other kind of materials. So if there is a market, it's about having also the commitment of let's not use virgin materials to build Zeta facades, and with the circular construction value chain this would be feasible. It's more about transforming the industry more than the technology itself. And then let's say that the it's true that the insulation material that we are exploring with our partner Indresmat, it's a new material. So we don't have that already available in the building stock. So we cannot mine that material because it's a new material that we are producing. But the good news is that at least it comes from biosources. So we are substituting petrol to do an insulation material, and it comes from biosources, so which at least it's better with less emissions related than if it was petrol based.
Something that you mentioned in the Zeraf overview of this, of it being a technology to take to market and being a financial success as well as just a technological one. In political times where climate is becoming less and less of a priority in certain large nations and to certain large parties, does this being a financial success or a strong financial prospect give you more confidence that it could be taken forwards? Environmentalism goes beyond just saving energy or saving the trees, but it is a money-making endeavor as well. It will make jobs. It will succeed economically.
at least for the European market, that it's the one that I am focused right now. I think that the key aspect that a technology like Zeraf can bring us is energy autonomy. So at the end, having less consumption in the European Union means to be less dependent of other countries. So something that even if you don't care about climate change or if we meet or not the target of 2050, already today we decrease the dependency that we have towards other nations, it's something positive to the current political situation. And the same of making the technology compatible with circularity. At the end, circularity in the built environment is also a great chance to be less dependent from other countries. So to strengthen our economy and have gains that don't come from destruction of raw materials, but from creating new services and also new manufacturing. So there is a great potential there. In that sense, in the project of Zeraf, we have also great opportunity because we are in this change of paradigm of the facades. The facades are not anymore something that you install and you forget about it, and maybe in 50 years or 100 years you come back and you demolish and you do nothing with it, but you want to keep it operating as best as possible, which means to update the control algorithms that you have there and to have that minimum monitoring and also control that it's something that we accept for our heating and cooling devices. So now these kind of services would also be related to the facade industry and maybe offset from these systems that they are going to be useless or not even maybe for some climates, one of the two, because you can deal with the facades. So it's an opportunity, of course, of job creations. And also one of the problems that maybe I didn't mention before in the construction industry, it's that we don't have enough labor, so enough people working in the industry because it's a tough work and in tough conditions. So maybe some of the concepts that I presented you in the beginning, they just focus on how I can make this technology from really highly insulating to not insulating. But then at the end, it was about putting some openings in a brick wall. And with Zeraf, we are, let's say, the capacity of think of a completely new technology, which means that can be directly aligned also with other trends in the construction industry or needs of having a product that it's industrialized, that it's prefabricated, so that you can do it off-site in a comfortable conditions and safe conditions for the workforces, and all the complexities that the facade can have is deal with in the manufacturing site and not in the construction site, so that there is simple. So you need also less people and you can have more control on it. So in that sense, the transformation of the construction industry that we see thanks to the completely or radically new product goes also in this direction.
Looking back on Zeraf, looking back on Façades, looking back on the change needed in the construction industry, and hopefully something that's going to keep us all alive into 2050 and beyond, what would you say is the message to anyone listening to this if they are working in the construction industry, or maybe if they're in policy, or maybe if they're just a member of the public who wants to know about how architecture is meeting environmental challenges?
Let's say that from today's interview, I would like in general all the citizens to reflect on how traditional construction industry is and how reluctant we all are when it comes to innovation in the construction industry, because it's something that once that it's built and it's there, it lasts maybe so much that people are less likely to take risk, and usually it also takes a lot of money to have a building constructed, right? So the general approach is to be really conservative, but my message today is we cannot continue like this because we are not answering even to today's problem if we keep building like that. So maybe this approach worked 50 years ago, 100 years ago, but now we need to change so that what we are building today or how we are renovating the buildings today are effective in 25 and hopefully contributing to meet our targets in 2050. So I would ask to everyone to be more open to innovation in the construction industry. So from the citizen that at the end needs to also accept seeing the buildings being built completely in a new way. So with reused materials, with facades that are able to modulate the heat, that are managed while before were just static. And of course, to the decision makers, so also to policy makers, to be aware of all the trends in the research environment so that they update and make ambitious their targets. And to the sector in general, it's really hard to approach because construction sector is very compartmentalized. So we have many small, medium enterprises. So to all of them, my message would be the same. You cannot continue working like that to have a good quality building now. So please accept the challenge and be open to do things differently.
And if people want to know more about doing things differently and Zeraf, are there any useful websites that we can link them to now?
So to be updated about our research, you can find news about it in our project website, the Zeraf Technology project website, our LinkedIn, that it's also Zeraf Technology, and overall Eurac Research webpage. You can find more information there. So as soon as we have public deliverables and news, we post them in these three sources.
Thank you so much for your time today, and I look forward to hopefully having more conversations in more stable, sunny weather with you sometime soon.
Thank you very much.